It's time for math routines. Try to find a piece of paper and something to write with. If you can't, that's okay. You can always just solve in your head or solve using your fingers. Remember, you can pause the video anytime you need to if you need more time to solve.
Hey, first grade. I'm so excited to do math with you today. The first thing we're going to work on is putting numbers in order from smallest to biggest, least to greatest. Let's get to work. Another way we can think of ordering numbers is ordering them from lowest to highest in terms of their value. So let's get to work. Order the train's cars from lowest to highest. That means the lowest value to the highest value. Let's start by saying our train cars and their numbers. I see they already gave us the smallest one down here. This is the number. Good, 15. Let's go through and read the rest of our numbers. This number says, good, 35. This number says, good, 28. This number says, nice, 46. This number says, good, 65. And this number says, you got it, 48. So now we want to think about, if I start with the smallest number, or the lowest value, 15, which number would come next? I know good mathematicians always check the tens place first, because sometimes that can give us our answer. And then if not, we can check the ones. How many tens are in 35? Good, 3. How many tens are in 28? Good, 2. How many tens are in 46? That's right, 4. How many tens are in 65? 6, good. And how many tens are in 48? Nice, 4. So of these tens values, which is the smallest or the lowest? 3, 2, 4, 6, or 4? That's right. 2 tens would be the smallest number of tens, or the lowest value. Now we're left with, let's check the tens again and see if that'll work again. 3 tens, how many are here? 4 tens, good. How many are here? 6 tens, good. And how many are here? 4 tens, nice. Of these tens values, which is the smallest or the lowest? I agree, 3 tens is smaller than 4 tens and definitely smaller than 6 tens. Nice work, first grade. Let's keep going. Now let me check my tens again. How many tens in 46? Good, 4. How many tens in 65? Nice, 6. And how many tens in 48? You got it, 4. Which is the smallest value of tens? 4, 6, or 4? I agree. That's tricky. They tied 4 tens here and 4 tens here. 4 tens is definitely smaller than 6 tens, but which number comes first? If I want to go with the lowest value, would it be 46 or 48? I agree. 46. Why? That's right. 6 ones is less than 8 ones. So this value is smaller or lower. And then what's my highest value number here? That's right, 65. Now, first grade, we're going to work on some counting patterns. What that means is if you don't have a sheet of paper out already, you should hit pause and go grab one now. If you can't find a sheet of paper and something to write with, that's okay. Just do your best to follow along using your voice. So again, if you need to hit pause now to go get something to write with, Go do it. All right, friends, here comes our first counting pattern. Let's read this together. This number says, good, 342. Next number, 344. Next number, 346. So write those down. And then start thinking about, what is my pattern counting by? Or what is it making jumps of? If you said this pattern is counting by twos, you're correct. Because I know from 342, I can say just 342, 343, 344. I have 2 fingers up because that was 2 more, or a jump of 2. So this is a +2 pattern. See if you can figure out the missing numbers in the pattern that come next. Get to work. Nice job. After 346, 2 more would be 346, 347, 348. Good job. What would come after 348 in a +2 pattern? You got it, 350. Alrighty, next pattern, here we go. Read the pattern with me, get ready, go. 550, 552, 554. Write this down and figure out, what is it counting by? I agree, it's a +2 pattern again. Now see if you can figure out what comes next in my pattern. Get to work. Good. After 554 would be, well, I'm making 2 jumps. 555, 556. And what would come next in the pattern? Good. 558, because I could just count on 2 more. 556, and then 557, 558. Nice job, first grade. All right, last one. Count the pattern with me. Get ready, go. 226, 228, 230. So again, copy this down and figure out, what am I counting by? And then what comes next in my pattern. Get to work. So what am I counting by? Exactly, I'm making jumps of 2 every time. What comes after 230? Exactly, 232. And what comes after 232? Nice job, first grade, 234. You did a great job counting by twos. Now we want to think about 10 more, or +10. We worked on this a lot before break, where we talked about, it's really just adding a stick of 10 to whatever the number is. So for example, let's read this number sentence together. 365, read with me, +10 equals blank. How many tens are in 365? That's right, 6. So if I have 6 tens and then I add another 10 stick, what number would I have? That's right, 375, because I went from 6 tens to 7 tens, and the value of 7 tens is 70. We could also use our trick on the hundreds chart. We start with 365, And then for 10 more, I just drop down a row and land on 375. That makes sense because this is really just 10 jumps. So I can just be more efficient or fast and move down one spot. Let's do another one. Read the number sentence with me. Get ready, go. 554 plus 20 equals blank. Challenge. How many 10 sticks are in 20? That's right, 2. So how many 10 sticks would I add to 554? That's right, 2 more. How many 10s are in 554? Good, there are 5. I know because there's a 5 in the tens place. So if I have 5 10s and then I add 2 more 10s, how many 10 sticks would that be? Right, 7 10 sticks. So 500, but then it would be 7 10s and 4 1s. What number would that be? Exactly, 574. We can also use our hundreds chart trick. I start at 554, but if I want to do plus 20, how many times do I drop down on the hundreds chart? I know each move down is plus 10, so I could do plus 10, but then I need to go one more time to make it plus 20. 10, 20, and I land on 574. So that's another fast way to just add sticks of 10 to a number. Now we're going to watch a video on evens and odds, and then afterwards I'm going to have a few challenge problems to figure out evens and odds.
I was exploring an enchanted wood. A wise fox started talking, I somehow understood. She asked,
"Please, will you join me beneath this pine?"
She whispered,
"For you, even numbers I'll define. They are 0, 2, 4, 6, and 8. Even numbers all share one trait. You can split them down the middle. If they make pairs, you've solved the riddle. 'Cause 1 plus 1 equals 2, and 2 plus 2 makes 4, it's true. Then 3 plus 3 equals 6, and 4 plus 4 makes 8 big sticks. Numbers big and small, today we're gonna count them all. Some are even, some are odd. Won't you join our counting squad?" We walked further into the forest when a rat squeaked,
Please sit with me and be my guest. And I'll take the time to show you how to tell which numbers are odd.
We looked at the fox and she gave a sly nod.
The first 5 odd numbers in line are 1, 3, 5, 7, and 9. They are not divisible by 2, and for all odd numbers, the same is true. Between 1 and 10, there are 5 of them. Now I'll count the odd numbers again. 1, 3, 5, 7, and 9. They're every other number on the number line.
Numbers big and small, today we're gonna count them all. Some are even, some are odd. Won't you join our counting squad?
Then we were met by a barn owl, perched outside his birdhouse on a dowel. He said,
Please visit with me just for a short time, and I'll discuss bigger, even, and odd numbers as I rhyme. Bigger numbers are even or odd too, and the last digit holds the clue. So what about the number 72? It's even because it ends in 2. Or what about the number 93? That number's odd because you see, the last digit's the odd number 3, which means it can't be split evenly.
Numbers big and small, today we're gonna count them all. Some are even, some are odd. Won't you join our counting squad?
we wandered further into the wilderness. An alligator appeared from the darkness.
number to teach you. For you must learn about zero before your journey's through. Zero can't be split to make a new amount, but it's still even when you count. Cause if zero's a number's final digit, that number can be evenly split. For instance, consider the number 10. Let's split it in half and we'll see then. It makes 2 5s and that's a pair. If it ends in 0, an even number's there. Ha ha!
Numbers big and small. Today we're gonna count them all.
Ha ha!
Some are even, some are odd. Won't you join our counting squad?
Come on, join in!
Numbers big and small. Today we're gonna count them all.
Yep, all of them.
Some are even, some are odd. Won't you join our counting squad?
Numbers big and small. Oh, think it's over. Too much fun.
So now first grade, I'm going to give you some numbers, and I want you to use what you learned in the video to think about, is this number even or odd? Remember, we only really check the ones place because tens, no matter what, are always even. Even means you can split it in half and it's fair. So for example, I have a 10 stick here. I know I can split this into 2 even groups and make it fair. So you would have the same number, for example, as me. If I were to take this 10 stick and split it in half to make it fair, where would I split it? Which tens fact could I use to make this an even fair split? Would I do 7 and 3, 4 and 6? That's right, I could do 5 and 5. If I split my 10 stick or my group of 10 like this, you would have 5 and I would have 5. Is that fair or even? Totally. So tens are always going to be able to be split fair, whether we have 1 10 stick, 2 10 sticks, 10 10 sticks. That's why we only really check the ones place to see if a number's even or odd. So my first number is 22. Is 22 even, meaning we can split it fairly, or odd, meaning there'll be 1 extra left over? What do you think? Let's see if you're right. How many ones are in 22? That's right, 2. So I think about, if I had 2 ones or 2 cubes, could I split that fairly? Definitely. 1 for me, 1 for you. So does that make 22 even or odd? Exactly, even. Let's try another one. This number is, good, 83. How many 10s are in 83? Nice, 8. Now, we know we can always split 10s evenly, 5 and 5, and make it fair. So instead, let's really think about the ones. How many 1s are in 83? Good, 3. Can I split those evenly? Or would it be an odd number? Let's try it. 3 1s. 1 for me, 1 for you, and then 1 extra. So is 83 even or odd? Exactly, odd, because there would be 1 left over. Let's try one more. What's my number? Good, 447. Wow, this is a really big number. But I really only need to check the what? The hundreds, the tens, or the ones? Exactly, so let's check the ones. What's the digit in the ones place in this number? Good, 7. So would 7 ones be even, like fair, or odd, meaning 1 left over? Let's see if you're right. If I tried to split 7 ones and make it fair, I know that I would have a group of 3, a group of 3, but then 1 left over. So that would make this number odd. Now let's try some even-odd word problems. This says, Bucknell has 16 scholars. If they split into pairs, that means groups of 2, will everyone have a partner? Try to solve on your paper or talk with someone nearby. If Bucknell has 16 scholars and they're getting into pairs, will everyone have a partner or will there be like an odd person out? If you said even or odd, how do you know? Perhaps you're drawing a picture or checking the ones place. Maybe you're writing a number sentence. Will everyone have a partner in Bucknell? If you're still working, you can pause here and continue. If not, let's take a look at some work. One way to solve is to draw every student in Bucknell. So here I drew 16 scholars. I just used circles to represent scholars so I could be a little faster. Now I'm going to put them into partners and see, is this even or odd? When I put Bucknell into partners, everyone had a partner, which tells me this number's what? Even or odd? Exactly, even. Some of you know we can also check the ones place. If there are 16 scholars in the class, what's the digit in the ones place? That's right, a 6. And is 6 something we can split evenly, or is it an odd number when there's 1 left over? That's right, we can split 6 evenly, 3 for me and 3 for you. So this is an even number of students. So will everyone have a partner? Yes, everyone has a partner in Bucknell. Let's try another problem like this. Stonehill has 23 scholars. If they get into groups of 2 for a field trip, will everyone have a buddy? Get to work drawing a picture or thinking about the numbers, the digit in the ones place, or perhaps writing a number sentence. Get to work. If you need more time to solve, that's okay. Just hit pause. Let's take a look at some work. I drew 23 using 10s and 1s. I know 23 has 2 10s, so I drew 2 10 sticks, and 3 1s, so I drew 3 1s. Now, I know a 10 stick can always be split evenly, just like I showed you with my 10 stick here. So these 10s are even. So that makes me wonder, maybe 23 is even and everyone does have a buddy. Let's check the ones place. 3 1s. Would everyone have a buddy if there are 3 students left over? No, I agree. We'd have an odd student out. We could also look at the ones place just in the number itself. 23 has how many ones? Exactly, 3. And can we split 3 evenly? No, there would be an extra one. So no, everyone doesn't have a buddy because 23 is an odd number. Last thing for today, first grade, let's play Guess the Winning Number.